Hi guys, so today we're gonna be continuing our lesson in classifying conic sections, but this time we will no longer be using discriminants. Instead, we will only use the values of the coefficient A and C. So the reason to this is the term bxy from our original general equation is now equal to 0. Therefore, this term no longer exists in the general equation of the conic section. So if this happens, we will use the table here to identify what type of conic section it represents. Now, for the first condition, when A is not equal to C and they have opposite, they have the same signs, let's say they are both positive, the type of conic section is an ellipse. Now, when A is not equal to C and they have opposite signs, so let's say A is positive and C is negative or vice versa, the type of conic section is a hyperbola. Now, when either A or C is 0, the type of conic section it represents is a parabola. And lastly, when A is equal to C, the type of conic section it represents would be a circle. Let's now use these conditions to the following conic sections. For number 1, we have for coefficient A, that would be equal to 2 since it is the coefficient of x squared. For C, that would also be equal to 2 since it is the coefficient of y squared. Since A and C are equal, so it satisfies this condition. So it means this conic section is a circle. Now for number 2, for the coefficient A, so this would be equal to 3 since it is the coefficient of x squared. Now, for coefficient C, if you take a look at the equation, we do not have a term containing y squared, so it means C is 0. Now, if either A or C is 0, again, that would be a parabola. So this conic section is a parabola. For number 3, we have A equal to 9 and C equal to 25. Now, for this case, wherein A is not equal to C, but they have the same sign, they are both positive, this conic section is an ellipse. Okay? For number 4, for coefficient A, since we do not have a term containing x squared, it means A would be equal to 0. Now for C, that this is the coefficient of y squared. So since y squared is present, its coefficient would be equal to 1. So it is similar to problem number 2, wherein A is 0 and C contains a value. So it means this conic section is a parabola. Now for the last question, we have A here equal to 9 and C equal to negative 4. So A and C are not equal, and also they have opposite signs. A is positive and C is negative. Therefore, it satisfies this condition. So it means this conic section is a hyperbola.